Okay. Yeah.
Okay.
So we are very glad to be here to present our work on threat modeling for the OD Wallet ecosystem. So let's start with a brief introduction of ourselves. We are researchers of the Center for Cybersecurity of Fondazione Bruno Kessler, FBK, in Trento, Italy. Our center has expertise in several domains, like applied cryptography, cloud and IoT security, threat and anomaly detection. And Amir and I, we mainly focus on digital identity. In this context, we were and are involved in several research and innovation projects. For example, we were involved in the eIDAS notification of one of the Italian national aid schemes. And now we are involved in the large-scale pilot potential with a focus on the security of the European Digital Identity Wallet. So before going in the detail of our contributions, I want to give you some context and motivation of our work. So with the introduction of the European Digital Identity Wallet, we are facing a shift in the authentication paradigm. To understand, let's consider a typical interaction in eIDAS 1. So we have a user like Alice who wants to access a service provided by a relying party. To know who the user is, the relying party is going to request this information to an identity provider that then will authenticate the user and give this information back to the relying party. With this information, then the relying party is able to take a decision whether to allow the Alice to access the service or not. With the eIDAS 2, instead, we have two different phases. In the first phase, called issuance phase, the holder, through the wallet, is going to contact an entity called issuer to obtain a credential. And then, in a second phase, a relying party is going to request some data to the user, and the user has the ability to select the most suitable credential to then present to the relying party. And in addition, in some cases, the user has also the possibility to select a subset of claims containing a credential. So together with this property that is called selective disclosure, another important aspect is that the issuer and the identity provider are not involved anymore in this second phase. So they are not able anymore to track the activity of the user in the different relying parties. So to allow and to permit this new paradigm, the European Commission introduces new roles in the digital identity ecosystem. The central one is the EUD wallet instance that is provided by the EUD wallet provider. And then we have a list of attestation providers that are going to issue the credentials that then are stored and managed in the wallet. Together with the new roles, we have also the need to identify how the different entities interact to each other to exchange data in these different phases. And here you can find a subset of standards that are identified in the architectural reference framework. What I want to highlight here is that all these standards are going to introduce new assets that must be taken into account in the security assessment. So given all these changes, what we are asking ourselves is, which are the differences in terms of security compared to traditional identity management ecosystems? So can we reuse existing security assessment, or we need something more? So to answer to these questions, what we are currently doing is a threat model for the EUD wallet ecosystem. Our final goal is to provide a comprehensive threat model that, together with the threat, is going to specify the vulnerability that that threat is exploiting, example of attack techniques that an attack can use to carry out a threat, the corresponding risk, and also a set of security controls that are able to mitigate that threat. So this is our final goal, and later on in the second part of the presentation, Amir is going to provide some examples. What I want to highlight is that it's a work in progress. So So far, we have focused on 4 entities: issuer, wallet provider, wallet instance, and verifier. And we have identified around 50 threats and security controls, and around 30 vulnerabilities and requirements. Even if it's still a work in progress, we decided to publish our work. You can find it following the link or scanning the QR code. And the idea is to receive some feedback on both the methodologies that we are following and the content itself. This work has been done in collaboration with the Italian Printing Office and Mint, and with our researchers, Daniela Pono of the University of Munchen. So this is the introductory part, and now I'll leave the floor to Amir for a deep dive.
Thank you, Giada, for the introduction. So, as Giada mentioned, so we started with identifying a set of requirements, security, privacy, and technical requirements. And in the next couple of slides, I'm going to provide you with some examples of these identified requirements. What I want to highlight is that at the time that we did this analysis, we do the analysis based on the ARF version 1.3, and we are going to extend our set of identified requirements with the new ARF. So considering the security requirements, let's take a look to what we call issuer identification. And what we mean is that the credential must contain information that is required to identify the issuer in order to ensure that the issuer can be recognized and verified by the entities that are involved in the ecosystem. And we have the phase, which means in this requirement is related to the which phase of the UD wallet ecosystem. It's related to the issuance phase, or it's related to the presentation. So for the privacy requirement, let's consider the selective disclosure mechanism. I think everyone is familiar with that. So selective disclosure, we consider it as a requirement that is needed to be satisfied both by the credential format and the wallet itself in order to support the selective disclosure mechanism. And the idea with the selective disclosure mechanism is that to allow the holder to provide only the necessary, only a subset of claims that are necessary to access a service, and avoid unnecessary exposure of personal information. And it is relevant to both issuance and presentation phase. And to give you an example of the technical requirement that is coming from the ARF, let's consider the usage of the national eID infrastructure, which is needed in order to perform the holder authentication process during the issuance phase. So now let's move on to what we have done on the threat model. So as Giada mentioned, it's a preliminary analysis, and we try to identify a set of threats. And for each threat, our idea was that to define what is the threat category, what are the potential attack techniques, the relevant vulnerabilities that could be exploited, by that attack technique, and a set of countermeasures, security and privacy measures to avoid this potential threat. So for the threat category, we are following the standards. So for the security one, we are following the STRIDE, which is the framework provided by Microsoft. And it provides categories such as spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So I think everyone knows what denial of service means, and it's a threat action that attempting to deny access to the valid user, such as by making web server temporarily unavailable. In the context of wallet, it can be applicable for all the entities. So for example, you can send lots of requests to an issuer in order to avoid its services. And for the privacy, we are using the Lindon, and Lindon provides categories, threat categories such as linking, identifying, non-repudiation, and so on. And another thing that I want to highlight before going to the example is related to the assets that we identify, and the methodology that we, and as it is mentioned, it is work in progress. So what we tried is that not to take only consider the entity as a whole, but consider its interfaces as well in order to identify all the services and interactions that it can have during the issuance or during the issuance phase, in this case, as it is issuer. So just as you can see on the left-hand side table, so we try to provide some coding that you will see this code in the analysis table that we have provided. And for example, as an issuer data, we consider the issuer private keys, the config files, and as we are focused on the OpenID for VC stack, so we consider related data to the protocol, like such as the code and access token and so on. So now let's consider some examples that to give you some idea that what you will see in the results table that we are sharing. So let's consider entity impersonation. Entity impersonation is a threat that involves a malicious actor playing the role of a legitimate entity. And the threat category that we consider for this threat is the spoofing, information disclosure, and identifying. And the attacker can use a simple attack technique like creating a replica of legitimate issuer, verifier, or wallet, and then using social engineer technique to deceive the user to interact with the fake entity instead of the legit one. So the vulnerabilities that it could exploit would be simply human weakness or having lack of a secure entity registration process. And the control that you can have in order to avoid this threat could be either the entity training or having a secure entity identification during the registration phase for onboarding the issuer, verifier, and wallet. So the second threat that I would like to speak about it is the use of a stolen credential. That an attacker can steal the credential somehow and then tries to inject it in this session with the verifier in order to legitimately access some service of the verifier. And the vulnerabilities that it can exploit here would be lack of holder binding or lack of having a proper mechanism to avoid the injection attacks. And what would be the control here would be simply the use of ephemeral credentials or having the holder binding, or providing mechanisms for the holders to revoke the credentials. And the last one, so the previous two was like general, that could be applicable for all the protocols, and this one is very specific to the OpenID for VCI, because we try to separate the threat analysis that we have. So one part is like all the general threats that could be applicable to all the protocols, and then we have a specific part that is related to the OpenID for VCI stack. So considering that, let's consider access token theft that an attacker can use, for example, use an attack technique like man-in-the-middle attack to intercept the messages between the issuer and wallet in order to store sensitive data such as tokens, and then it can exchange it to obtain the credentials. And this can happen by exploiting lack of secure communication or the use of bearer tokens. So in order to avoid this, you should have the secure communication implemented using TLS, or you have to use a sender constraint access token. So just to say that what are the ongoing work and what are the future steps. So we are trying to refine the protocol-related threats. And we started to define a set of specific threats regarding to the secure storage, considering the different options, like if it is on device, like regarding TEE, secure enclave, or if it is a cloud solution, like considering the HSM, and try to define the specific threats that could be applicable for each of these secure storage components. And we want to complement our threat model by performing a risk assessment. And as a future work, we are trying to add some new roles that are not that we are not considered so far in our threat model. So like considering the authentic source, the qualified trust service provider, and so on. And then we want to define some threats related to the trust model. And after that, we would like to take a look to the wallet implementations to see if they have some, we have like two ideas regarding data. First, check if they are compliant with the regulation, and secondly, if the threats that we have identified has been addressed by them or not. And to conclude, so we start from a concrete problem that is, I think, is obvious to everyone, that ensuring the security of eIDAS wallet and its environment is crucial for protecting citizens' data. And the motivation beyond the work was that the current draft and recommendation, for example, the architecture reference framework, it doesn't detail implementation guidelines for securing the wallet. So as a considering solution, we start with a threat model. And we think that the result of the threat model can be serve as a reference tool for stakeholders, because we have like kind of classification based on different stakeholders. So if I'm an issuer, I can just take a look what are the threats that are applicable to me and to be sure that I'm not exposed to them. And I think that's all. And we are looking forward for feedback and collaborations from the community.
Thank you, guys. We could take a couple of questions if anybody. Yes, please. For both of you, obviously.
Hey, so on the slide where we showed the eIDAS 2 authentication model without an IDP interaction, you showed that the information went from the wallet directly to the relying party. Is that data copied verbatim from the wallet, or is that derived from the data in the wallet?
So, do you want to reckon?
You can start.
So it depends that if when the presentation request is coming from the verifier to the wallet, so if I have a credential that could satisfy the request of the verifier, so it goes directly from the verifier, from the wallet, one of the credentials that is already stored in the wallet and going to the verifier. If I don't have a credential that could satisfy that, then you can go to the issuer, you obtain it, and then you can share it with the verifier.
Okay, thank you.
You're welcome.
Thank you. One more question, just in the second row. Yes, please.
Just a quick question is if you compare it to eIDAS 1, like the new eIDAS, does it have already more security threats that you have found, or what's the plan?
So the general ones, so it's like a mixture that could be applied for any identity management solution. But then we have some specific threats that are related to either some new terms like wallet instance attestation, that could be like related to the fact that if the wallet is genuine or not, and how you are obtaining. And then another thing that is like makes some difference is like you have some new entity like wallet provider. Then we are considering some threats between the interaction between wallet and wallet provider that is specific to eIDAS 2. But yeah, we have a set of threats that could be applicable to all the identity management solutions, and then they are a subset that are specific to the eIDAS 2.
Okay, thanks. And was a question here, right at the front? No,
Yeah, thanks. One question. You showed an example where you identified a threat based on lack of the usage of TLS in the flow.
Okay.
So my question is because as far as I know, the OpenID for VCI specification prescribes the usage of TLS almost everywhere.
Yes, but
So-
if somebody is using TLS 1.2, for example, then they are, I mean, okay, having something in the specification is one thing, and if you're implementing right or correctly is another thing, okay? So it would be still some possibility if you're using the old version of TLS, for example, that is still...
Okay, because my
Yeah.
concrete question would have been, how many threats would you have identified which are not based on the lack of usage of TLS? Which is it like half of it, or?
I have to take a look.
Okay, yeah,
Yeah.
never mind.
Yeah, because what you can, if you already take a screenshot of the, so I mean, you scan scan the QR code for the table. So I think you can simply filter it based on the attack techniques that are based on man-in-the-middle attack. Then you can see all the ones that could be exploited by lack of the TLS.
Thanks a lot.
You're welcome.